This presentation was brought to you by the Northern Colorado Amateur Radio Club. Thank you for watching, and don't forget to like and subscribe.
Something about Raspberry Pi, Arduino, etc., etc.
Well, I am not a lot. I don't have a lot of info about it, but I'm hoping that a lot of people will. So I guess we'll swing this off. I just saw my clock beep. My braille display is slow. So good evening, Northern Colorado, and welcome to the NCARC TechNet. We meet each Monday evening at 6 o'clock on this frequency to discuss amateur radio-related issues, usually of a technical nature, sometimes very elementary technical, and sometimes more advanced. Anybody is welcome to participate. We also have the 447.75 repeater linked here, as well as Echolink at NCARC-R. No, W0UPS-R, excuse me. We welcome all views and opinions. They're, of course, not all necessarily those of management of NCARC, but that's okay. I will let you know again that we have an email. You can contact us if you have questions about the net, questions you'd like to have brought up on the net, or if you need assistance with radio-related matters. Email elmers at ncarc.net. That's ELMERS at ncarc.net. So this evening, we'll take some check-ins and then start with the topic. W2MIC, I'll put you first on the list there. Others, please?
This is K1DEG in Platteville. Mike?
Kilo Niner Sierra Charlie Whiskey, Shannon, Fort Collins.
This is KE0PUQ, Bill, Loveland. This is AE0BQ Alpha Echo 0 Bravo Quebec, Daryl in Longmont. Kilo Delta 0 Tango Yankee Uniform, Joe in Loveland.
This is Kilo Echo 0, Lima, Charlie, Kilo. KE0LCK, the other Mike from Windsor.
This is KE0RXF, Randy, Fort Collins.
This is KE0SPS, Kevin, Fort Collins.
Wow. Right, let's go through these. Couple of questions. Kilo Echo 0 Sierra Papa Sierra, is that right? And is the name Ted? was the very last call I heard.
Correction, it is Sierra Papa Foxtrot, and this is Kevin.
Okay, Kevin. You know, I thought that's what I heard, but I wasn't absolutely sure. Well, welcome. I've got your call corrected here. KE0RXF, KE0LCK, KD0TYU, AE0BQ, KE0PUQ, K9SCW, K1DEG, and of course W2MIC I already recognized. Anybody else?
Good evening, Kevin. This is Whiskey Zero Delta Delta Zulu, Dave and Greeley.
This is Lauren, KG0HM.
This is Kilo Echo Zero Papa Tango Echo KE0PTE Mike in Fort Collins.
Welcome back, Kevin. This is Whiskey Zero Alpha Sierra Papa W0ASP Terry in Berthoud.
W0DAS Whiskey Zero Delta Alpha Sierra Dave in Fort Collins.
This is Alpha Echo Zero Charlie Foxtrot Ben Fort Collins. This is George, KB0SCX in Berthoud.
Whiskey Zero Uniform Sierra Charlie. John in Livermore.
Goodness gracious, Dave, what'd you do to this net last week? Welcome W0USC, KB0SCX, AE0BCF, W0DAS, W0ASP, KE0PTE, W0DDZ. I hope I didn't miss anybody. Did I miss anybody in that last round, or is there anybody else?
This is Lauren, Kilo Golf Zero Hotel Mike, Fort Collins.
Okay, I heard a click, but nothing else. I'm really sorry, KG0HM. HF, I think. I'm sorry, Lauren. I'm really blowing it today. Anyway, I did hear you. I thought I wrote you down, and I didn't see you. That was kind of strange. Anyway, I'm checking here. It seems like there was somebody else I missed, too. I was quite sure there was somebody else, and I don't remember reading the name. W0USC, oh, I see him here. W0USC, John. Welcome also. Sorry, I'm a little disorganized. My trip was wonderful, but it was very tiring, and I'm still recuperating. Okay, anybody that hasn't checked in is still welcome to participate and check in later on. We'll be more than happy to take you. But I think we'll go ahead and get started. I am hoping that we have some folks that have played this game a bit, so that they can add their experience levels. Had a request to talk about the Arduino and the Pi and their uses in amateur radio, and I do know that they are being used. First of all, if you're not aware, those are the Pi is actually a small Linux computer. It will run various software just like any computer, but they're like 3 by 3.5 inches, and there are smaller versions even than that, and they run off of a compact flash card or USB disk. So, and 5 volts. Very, very neat little packages, and very capable of doing lots of things. And the Arduino is what did they call those, microprocessors? There was another name for them which I can't say right now, but essentially a little processor that you can program with a specific language set to do various things. I have one here that beeps Morse code at me, and it measures the battery voltage in my backup battery and beeps it back in Morse code. I was really, really proud of that little I am really, really proud of that little project. So, with that, let me entertain further questions, and then further information from people who have perhaps used these in radio and what they would like to add to what we've talked about. Questions first?
W0ASP with a question.
SP, go ahead.
Kevin, I'm familiar with the Raspberry Pi, and it is a small Linux computer, and it does what a Linux computer will do reasonably well, but not with the Arduino. It seems like it's more of a microcontroller that's meant to interface to hardware and turn bits on and off. And I think the Raspberry Pi has a hard time doing that. Am I wrong?
Yeah, good question, Terry. Yes, microprocessors, microcontrollers, what I was looking for. And it does have pins that can turn things on and off, as well as pins that can monitor the state of switches and controls and other sensors. The Raspberry Pi also does have a set of pins that can be used to at least control and perhaps sense various things. I believe it is a little more sensitive, not as durable electrically, and you have to be perhaps a bit more careful with it, and it may be a bit more limiting because of the maybe amount of pins that can be used for that, or something of that nature. However, there may be expansions that I don't know about that can change that situation. So yes, in a sense you're right, but I've seen plenty of projects that use those pins on a Pi to do that same sort of thing. N7GES and the TechNet. Other questions?
DDZ with a comment.
Thank you, Dave. Go ahead.
Yeah, I just wanted to expand on what you were saying there, Kevin. So the real, like we've said, the Raspberry Pi is a small Linux computer, whereas the Arduino is a microcontroller. The biggest difference between them is going to be that when you're programming something onto the Raspberry Pi, you're making a program in Linux that is going to be run. It is going to be run on top of an operating system. When you're programming something on an Arduino, you're programming directly onto the chip itself. So the real advantage that a Arduino has over a Raspberry Pi is loop speed, where the advantage that the Raspberry Pi has over the Arduino is functionality. So I've made a project using both a Raspberry Pi and an Arduino. It was a RFID tag reader for a kegerator. And I originally tried to do it all with the Raspberry Pi, and that did not work. Well, it worked okay, but the problem that I ran into was that the Raspberry Pi's loop speed was not fast enough to catch the RFID tag every time that you swiped past the sensor, whereas the Arduino's loop speed is so much faster, so every time you put that card near it, it's going to detect and read the card, where the Arduino doesn't have the ability to use like other software. So I had the Raspberry Pi running the web interface and a MySQL database and all of that stuff, and then the Arduino actually ran the hardware to run the RFID tag reader as well as the solenoid valve and flow sensor on the kegerator, the actual hardware that was on it. Hopefully that clears some of that up.
Well, that was huge for me, and I appreciate that very much. I had forgotten about the speed issue. Some people think that maybe the Arduino speeds are limited, but if you consider that it's not running a whole operating system and stuff, I guess that makes a big difference. Thanks very much. Other questions?
E0CF comment.
Go ahead, CS.
Well, I'd just like to point out that the main reason that the Pi seems slower is not really that slower. It's rather that it's not consistent, as in the OS needs to run parts of the code once in a while, and then it's just like if you want, let's go back to like a clock. Like you have a pulse every second, let's say. Sometimes it's not this slow, but the Arduino can hit one pulse every second. However, due to what do you call this? Due to I guess cleanup tasks, not really cleanup tasks, what's right, I can't think of the right word right now, but sometimes it will take 1.1 seconds or 1.2 seconds, and sometimes it might hit 0.9 seconds. It's not consistent. That's why it seems so slower, and it will miss some events. Back to net, E0, yeah.
Yeah, exactly. So the machine may not be slower, but the operations can be. Very good, very good explanation there. That's good. Thank you very much. Other questions before we go further?
AE0BQ with a comment.
BQ, go ahead.
Right, I just wanted to second what the first respondent said. I didn't catch the call. So the distinction between the two systems, the Pi and the Arduino. Yes, Linux-based 32-bit microprocessor, gobs of RAM, interrupts the old operating system thing, and then the Arduino, yes, microcontroller, fairly low speeds, 16, 20 megahertz clock rates, but out of that you get all of that horsepower to bring to bear in your program, including the determinants, determinism, which is just a fancy word that means how precise that you can toggle a pin, for example. Operations back-to-back, as you mentioned before, the timing is very precise. Not all that fast. 16 to 20 megahertz is plenty for doing braille decoding and certain kinds of things, hardware I/O with peripheral devices. And in Raspberry Pi, yes, full-on operating system, lots of things going on, lots of things that do not have directly anything to do with what your program is trying to accomplish. And so the determinism is really what's primarily different, although the Raspberry Pi Broadcom processor very capable. And I forget what the clock rate is. I think it's 8 gigahertz on the Model 3. Crazy fast, on the order of the desktop speed. But you are bound by your program is bound by the ability to get signals or read and write signals through the I/O pins. There's a number of techniques that are used. There are libraries that will monitor and sort of do the Arduino thing in what they call kernel mode, and there's a distinction there too in Linux rather. Kernel mode runs at pretty much full processor speed and has access to all hardware registers and everything, and then your program is generally going to be in user mode, which is has a virtual address space and file access and limitations. And anyway, there's workarounds for that, and that's so. I think the second respondent was looking for the word interrupt control or interrupt handlers. Yes and no. Those things execute very quickly in kernel mode under Linux on the Pi, whereas interrupt handlers take away from your nearly invisible on Linux and on the Arduino. The interrupt handlers you can have interrupts or not. You can choose to have programmed I/O, as it's called, or handle hardware events with an interrupt. That's where the processor your program essentially is interrupted. It goes to service that through an interrupt handler. It handles some sort of real-time I/O that has to occur on a precise interval, and then returns to where it was executing in your program. That happens on both systems. It's optional on the Arduino, and it is not optional under Linux, and there are
Node 1,
literally
2,
hundreds
7,
of interrupts going on with
5,
timers and operating
timeout.
systems.
Okay, Daryl. Unfortunately, you timed it out. But I think we got the gist. We got all but the last maybe 15 seconds of what you said there. And some good points, some technical points, but highly related to what we're talking about in a sense that there are certain things that you could certainly do more quickly or efficiently with the Arduino, especially when it's controlling external pins. But there are a lot more things that you might be able to do, or at least a little more easily, with the Pi. And some of those things aren't going to necessarily relate to output pins. So it may not be switching stuff, but it may be doing other sorts of things, such as displaying things, decoding audio and encoding audio signals. Oh, which reminds me, Daryl, did you say decoding Braille or something else at that one point there?
I think I said peripherals, doing I/O with peripherals, but sure, Braille displays work. I used to, just coincidence, I used to work for Blazy and then Freedom Scientific for about 11 years, so I've done some work in that area. AE0BQ, back to net.
Oh my goodness, how interesting. Small world. Well, I've used both of those. So very good. We'll have to chat some more sometime on that, just for fun. Yes. So anyway, so let's talk about some of the things that people are using those devices for in amateur radio. Would anybody like to start off on that? Is anybody involved in this kind of project at this point? This is N7GES and the TechNet.
SCX.
CX, go.
Before we talk about amateur radio projects, I wonder if the Arduino has debugging facilities. And I noticed that there are many Arduino boards that even use different processors. And can somebody comment on the different flavors?
Okay, would anybody like to tackle that one? I can probably give some basic info, but there may be more in-depth things. Debugging and different processors.
DDZ.
I heard double, but I heard DDZ. Go ahead, and then we'll catch the other station.
Both the Raspberry Pi and the Arduino are both programmed completely by the user. Debugging is definitely possible, but you're going to have to write some mechanism to debug into your code as you're working, if you know what I mean. The variant of processors, well, both Arduinos and Raspberry Pis have variants of processors, and really with the Raspberry Pi, as time has gone on and technology has gotten cheaper, they've put more powerful processors into them, where they used to, I think the original processor was around 500, 600 megahertz. Now they're up to dual core 1 gigahertz processors with I think they're up to 2 gig of RAM now, where the original one, I think it had 500 meg of RAM. So the various generations of Raspberry Pis have kind of upgraded similar to how computers have upgraded, just getting faster, really. The various different processor microcontrollers that are on the Arduinos are really going to relate to how many pins that the device has, and whether those pins are analog or digital, which is actually brings up another shortcoming of the Raspberry Pi, that all of its GPIO pins, which is general purpose input and output pins, all of those pins are digital only, where many of the Raspberry Pi, or I'm sorry, the Arduinos have analog input pins, which will give you the ability to do things like temperature readings, or like a read from a hydrometer, or whatever the case may be based on the analog input. So really, though the differences in processors on the Arduinos is more a function of the pins and what they accomplish. W0DDZ.
Okay, and the other station?
This is AE0CF. I just wanted to mention about the debugging. The Raspberry Pi is pretty much just a regular computer. You can get IDEs for it, just like a Windows machine, or you can run GDB or whatnot. The Arduino, however, since it's a embedded system, I believe the newer ones, there are IDEs that can single step through the processor, which makes it a little bit easier to debug. I also want to make another comment about Arduino. Arduino is not really a processor system. It's more like a development environment. So I don't know if you can, you've heard of like AVR, ML, or the ARM. I've actually seen some Arduinos that actually use ARM as their base processor. It's getting a little bit technical here, but that's the issue that's at hand. Back to.
Okay, thank you. And let me just add a little something, George. Maybe this is a little simpler info, but one of the other big differences in all the different models, too, besides all the processor power, which you may or may not notice depending on what you're doing, is the size of the whole device and the type of pins or number of pins that it has. Therefore, changing what you can do with it. They have some of these things that are so tiny, and they can embed them into cloth and clothing and things like that, or bracelets type things. When I first programmed my Morse code power meter, it was on the board called the Uno, which is a 3x4, 3x5 board, and I then transferred that program to what was it? Dave will have to remind me. But it was about a inch by a half inch chip. The same program runs on it. It had nearly the same pins, but it fit on a small board and fit inside this project. And by developing the thing on the bigger board, I could then just transfer it straight over to the little processor, and there you go. So, variety of things differing by the size of the board, the number and type of pins, and of course some differences in the processor. Does that help a little bit, George?
Yes, sir. Thank you very much. KB0SCX, back to net.
And I think it was the Nano that we found for you, Kevin, W0DDZ.
That was a double. Dave, were you trying to tell me Nano?
Yeah, that's affirmative. I believe we got you the Nano.
I believe that's right, too. Who was the other station there? Come again, please.
AE0BQ just wanted to volunteer. Yeah, it sounds like a Nano. Back to net.
Yep, I finally remembered. Okay. Well, let's get back to amateur radio. We've gone really deep into the computer side of things, and that's good because we've sort of determined what we might use for what sort of applications. Let's talk some specific applications. I mentioned one, which I created, and which I do find incredibly handy, but there's an awful lot more of them out there. Would anybody like to comment on those? I might just start by making a few quick mentions of some things, such as APRS, and in various forms of APRS, both the decoding of the audio blips and beeps that we hear on the radio into the proper data that we expect to see on our map screens or message screens, and handling of the GPS, and even completely controlling the radio to run the APRS. So that'll be the starting point that I'll throw out, and let's see what other people have to offer here. N7GES in the TechNet.
DDZ.
DDZ, go ahead.
I'll just throw one out there too. There is a device that goes on top of the Raspberry Pi called I think it's a DV Mega is what it's called. But it allows you to create a digital voice hotspot with your Raspberry Pi that you can use to get into D-Star or DMR networks through the internet, such as a micro little repeater.
Okay, very good. And there are a lot of people using things like that. Sometimes it's a standalone device that is purchased, and sometimes it's a device that you attach to a Pi or something else. Anything else anybody wants to offer?
AE0BQ with a comment.
BQ, go ahead.
Right, I've had this ongoing project for a while now, but there is a company out of, I think it's somewhere in Eastern Europe, SV1N something or other, makes VHF and UHF modules, little canned modules about 2 inches by 1 inch, maybe a little bigger than that. And you power it with an Arduino or something similar. Take a reset breaker. And so I've been working on that, and that's an application. So you can actually use it to control the rate. There's a serial interface to this module, these modules, the UHF, VHF modules. And so you can actually create a low-power transceiver, QRP, with an Arduino and this board, so and an antenna of sorts. That's it. AE0 back to AE0BQ back to net.
Very cool. So you can build your own transceiver, essentially. Very cool. And I will add to that, a lot of people have been playing with the SDR, software-defined radio dongles, for at least receive. And I did have mine running on my Pi as well. So certainly no reason that it wouldn't. Depending on what you want to do with it, you might have a bit of a slowness problem or a memory problem if you're wanting to use a lot of graphics or a wide spectrum display or something. I was simply decoding audio, and that worked very, very well. So just another application. Anybody else?
CF?
Yes, go ahead.
One of these things I recently saw about the Pi, some versions of the Pi actually have a onboard frequency shift key or something like that. And people have actually been able to make a transmitter with just this one GPIO pin. I was kind of surprised. Of course, it's going to be square wave, and thus it has a lot of sideband and junk, and you had to filter it out. And plus, it's not very powerful. But you can make a transmitter with just Pi by itself, at least some versions of it. I don't know which ones. Oh, sorry, AEZO, CF, back to net.
Very interesting. Okay. Others, please.
W0DDZ.
Go ahead, Dave.
An Arduino project that I've been thinking of for a while is to make an advanced fox for a fox hunt, something that will only transmit at random times and won't, be transmitting all the time, and make it a little more challenging, perhaps change the power levels just to throw some wrenches into a fox hunt.
Okay. Would you be using a regular transceiver off of that? Since you want something that can change powers and stuff, I'm assuming you're going to have to interface more to the transceiver than just the typical in and out audio.
Yeah, that was my assumption, to use an Arduino and like a Bofang to make a fox that is not going to cooperate as much as just a standard fox where everybody waits 30 seconds for it to transmit.
Absolutely. Well, there you go. There are people that are already doing this sort of thing. Sometimes not as complex as what Dave's talking about, but certainly a self-contained transmitter that will do various sorts of sending at certain intervals. And so certainly there's no reason a person couldn't go beyond that to make it do some very interesting, crazy things. Yeah, very good. Others, please. Anybody using something right now, by chance, that they've either made or put together or programmed or whatever?
N0WIQ, and yes, I have used a Raspberry Pi and a DV Mega, and the DV Mega is the transceiver so that I can use it on D-Star. So anyway, that's my comment.
Okay, yes, very good. And we did mention that earlier, and that's certainly something I know a lot of people have worked on. So very good, thank you. Anybody else at this point? Anybody used one for a repeater controller yet? I think we doubled. I think that was Carrie. Come again.
Well, I was going to add up to that as I think the DV Mega can be adapted to an Arduino also, because I think I've heard of that being done. I don't know positively, but I just wanted to add that information. So, and the transmitter in that thing is worth about 10 milliwatts. So I'll also put out that comment.
Well, it's enough to communicate with your HT and get the information you need there. So there you go. Anybody else?
CF.
Yes, go ahead.
Well, currently, I really don't have any radios other than this 70 centimeter radio, and I actually have a non-functional, well, actually not non-functional, but it's really old 2-meter radio, and the problem with it is that it doesn't have all the crystals I need, and I'm currently trying to build a crystal eliminator for this 2-meter radio using not Arduino but AVR microcontroller. AE0CF.net.
Wow. Okay. That would be very, very cool. So essentially you're almost building your own PLL then, I take it.
Indeed it is. I might end up trying to build a HF radio with based it on what I learned from this. Back at AE0CF.
Okay, thank you very much. Is it Charlie Fox or Charlie Sierra? End of your call.
Charlie Foxtrot.
Okay, thank you. I've bounced it back and forth and never quite gotten it right, Ben, so thank you. I'm going through and fixing all my references, so I'll have them right. Thank you for mentioning the actual radio, because that reminds me of the wonderful BitX 40 and the MicroBitX, both of which are based on a type of Arduino they call a oh my, wow. Arduino, I think. Radio, anyway. So it's controlling a PLL board. It is controlling the switching of transmit and receive. It's controlling the display of your tuner, of your tuning control, and controlling the tuning control. Because of that, you can change its functionality by changing the programming code. So, fascinating radios those are, and those of you who have already gotten them certainly can testify at how much fun you've had with them and how cool they are. Now this is N7GES. Now that we've talked about all of this, and hopefully we haven't snowed anybody over, do we have any additional questions? So maybe I should pose the question, just how difficult is this stuff to do? Do I have to write a program? Do I have to wire things? Do I have to, build circuit boards? All of this type of thing. And I guess the answer to all of this is yes and no. I would say that when I got my Arduino, it came with a breadboard, which I was able to just poke wires into and into the Arduino, and then I could load a library and a sketch, which is a program, into it from someone else, and not have to write a stitch of code and try things out. And they worked. And then I could go in and modify that code, even without knowing a whole lot about it, and make it do things that I wanted it to do. So I started out, of course, by having my light blink. I then went to making my buzzer buzz, And then I went to a CW transmitter that just transmitted, was set up as an example to transmit a basic message. And found that I could modify that message and send different types of things. I could change the speed and the pitch and various things, and that's where the power voltage meter came from that I put together. With the Pi, it would be a similar situation. Let me reset. Lots of programs you could download and load, or you could write your own program. You'll have to study up a little bit on how you use the pins on the Pi and what you can do and what you can't do with them, but you can do that and either plug them together with a breadboard, at least for testing. But if you want a permanent project, you would want to fasten it together in a good permanent way with solder, either to a board or something else. In my case, we used a what do they call those things? It's essentially a printed circuit board that's made like a breadboard. So it has holes like a breadboard, but you solder through them. So we just had to set the chip into the board, solder it in, and then solder wires around to the various connectors, and set it up exactly like I had set up my actual breadboard model, and it went together quite nicely. I did not do that soldering. I'll just let you know right off the bat. I wasn't even able to do the placing of the stuff because it was tiny enough I was having difficulty. But I did do the breadboard work on my prototype myself, and so I was really pleased that I could do that.
DDZ.
DDZ, go ahead.
Those are called proto boards, I believe, Kevin. W0DDZ.
Thank you. Yes, that's exactly what it was. Other comments or questions?
W0ASP with a stupid question.
I doubt it, but go ahead.
Well, I'm stupid. Maybe the question isn't. How do you program an Arduino?
Not a stupid question, and that's a good one, and perhaps somewhat the same thing with the Pi, because there's similar situations. There's no keyboard. There's no screen or monitor. There's all of that sort of thing. So obviously the Pi is a little more advanced, and you can hook some things to it, like a keyboard and screen and that sort of thing. The Arduino just has a USB connector, but you can connect to that, and using the Arduino software, the IDE, send programs to it, which you write on a PC or my Mac. I did it with it, and that worked fine. And then once the program is uploaded into the device, it starts running. Because if you're connected to USB, that's powering the board, so it immediately starts working if you haven't got errors in the program that the IDE trips up on and says, nope, you got a problem here, that you need to correct in the code. Or if you've got the syntax all right and everything, and it goes ahead and goes into the Arduino, it'll run but it just might not do exactly what you expect. But that's, part of debugging. Did that answer your question, Terry?
Kevin, partially. I've worked with something called a Ceridium board, which you have to write a program in some kind of specific version of BASIC and then compile it and upload it to the board. With your Arduino, what kind of language are you programming in on your PC?
DDZ.
Go ahead, Dave.
The Arduino uses C++, and then the IDE has a integrated compiler, and it compiles it and puts it onto the device itself.
So then to program an Arduino, you really need to program in C++?
That is correct. Yeah, the Arduino IDE uses C++.
E0BQ comment.
Go ahead, BQ.
Just wanted to add, there's probably a missing piece we're not talking about here. So on an Arduino, there's a little tiny chunk of code, either in an outboard device, a smaller microcontroller that's connected to USB, or directly on the Arduino, called the bootloader. And the bootloader initializes the USB port as serial, connects to the computer, and then the IDE talks to that. Once the IDE has uploaded your code through the bootloader, then the processor resets and you run your code. And that's a synopsis of it anyway. That's basically how it works. Yeah, and there's very little, just to throw in on this, debugging, nothing. You can toggle a pin, and if you have, I think most of the Arduinos support a virtual serial port back to the IDE so that you can actually print, using a printf statement in C, back to that virtual console and get some output that way. And that's really, really useful, because otherwise you're left twiddling an LED pin or something, or just looking at it with a scope. Reset break. And one other thing I wanted to just mention was that, never mind, I'll save it for later. AE0BQ back to net.
Now you got my curiosity up. And yes, I have used that serial output, and yes, that is very, very nice. It does give you some hints on things sometimes that would be very difficult to get otherwise. So you can get some output from it that is human readable in that sense. Terry, does that take care of your question?
Well, I guess a little bit. I would have a follow-up question, in that I've used small device C in a Linux environment to upload binaries to a device similar to an Arduino, but not an Arduino. It seems to me that with a device that's very adept at flipping bits quickly, C++, it seems to be very expansive, I guess is the right word. I'm wondering how, this is maybe a programming language question, how in C++ you can manipulate bits on the Arduino.
BQ, I think I can answer that one.
Go ahead, BQ.
Right, so don't be scared. It's not C++, raw C++ starting from main. The Arduino has essentially, there's two phases to the program. You have a startup sequence where you're initializing GPIOs and configuring registers. It's usually very short, because there isn't much to do often. You initialize a port to be an output or an input, and timers and things like that. And then there's a loop that gets called after that initialization. There's some little tiny bits behind the scenes, but that's basically it. You get an init function that you write, and then you get a loop function that you write. And there isn't any, they do use classes and namespaces and things like that to implement more higher level things like, I don't know, LCD display drivers and graphics output and things like that. But even the serial ports, things that print, things that are capable of printing, use C++ under the hood. But you really don't have to know C++ to write an Arduino program. You simply write the bits to initialize the ports that you need. And it's very high level and user friendly. And then the loop, of course, to do the operative things that you want to do. Depends on the complexity, but if you're just blinking an LED and reading a pen or something, then yeah, it's pretty simple. It's nothing like you would think. When we hear C++, we think, oh, object-oriented programming, classes and heaps and templates. And no, it's really none of that. Although they do use C++ for implementing some of the higher level functionality. E0BQ, back to net.
DDZ.
I'll just insert that I certainly didn't know C++, but I figured out a lot of what I needed to know by just looking at the example programs. DDZ, go ahead.
Just trying to expand on Terry's question a little bit. I'm not sure if we're getting above what we're talking about, but there are bitwise operators. Any C++ bitwise operator is going to also work on an Arduino if you need to operate at the bit level. W0DDZ.
ESP?
ESP, go.
Okay, that's starting to make a little more sense, because I always think of these Arduinos kind of on a machine language basis, and it seems like what you're really dealing with is a C++ program that reduces the program to something very simplistic for that Arduino processor.
DDZ.
DZ, go.
I wouldn't say that it's necessarily more simplistic, as it's not got all of the libraries on, and the space that you have to actually add libraries is limited, so you have to be careful in that respect. But there is main does exist. It's just outside of the loop, and there's always a loop happening, because that's how the process or the microcontroller is working. Is it does a loop and does whatever functionality is in that loop and then starts over again. But you definitely can write your own classes and include other classes or other components of C++ if you need those components at above the loop, so that you can do whatever functionality. Like, I've written a lot of what I've written for the Raspberry Pi, I do inside of a class, and then include that class and just have the actual loop itself be very simplistic. W0DDZ.
WIQ.
WIQ.
For the Raspberry Pi, at least, and I think for the Arduino also, there are example codes already written for doing many things. So you could just download one of those code samples and load it into the device. Because, well, that's about all I got to say.
Yep, that's how I started learning mine, and that works. Actually, before I had mine, I was reading example code off the internet and starting to get a handle on it. So that definitely works. All right, other questions. I know we've probably brought up questions in people's minds. Let's see what you've got. This is N7GES in the TechNet. No questions? Wow. Can't believe we've answered things that well. I will throw out just a couple other examples. There, of course, are many interfaces you can get for an Arduino, and of course, I'm talking more about the Arduino because if it's a Pi, of course, you've got USB, and you can run pretty much anything you might run, connect via USB to a computer to some degree anyway. So I'm talking more the Arduino. There are many different boards and modules you can get for them. There are sound modules so that you can both record and playback sound, or at least receive and transmit sound. And that's part of how people are doing things like APRS. There are many clock programs, or clock chips. There is even a WWV receiver, which you can get and connect to one. I have plans to try one of those at some point, if I can ever get the time to get started on my code. So that gives you the capability of handling audio, handling time synchronization. You can get both either wireless or at least Ethernet interfaces so that they can go on the web. What else would anybody like to mention for the Pi? GPS units that will connect directly, and for these various things, you may need a library, which is, you can just download and include in your program. So that's simple enough. Any other things people want to mention? People are using them for making their own weather stations. I don't know if you can get the accuracy. That probably depends on the sensors you use and how you construct your housings and stuff. But certainly, if you got a good sensor, you can certainly read it and get good results from it. Any other comments from what I've already been chattering about here?
Well, just say along those lines.
We had a double BQ. Was that you?
Yeah, I just wanted to say, shields and hats. Shields on the Arduino, the standard, Arduino platforms, the larger boards that have the pin headers, and then hats on the Raspberry Pi that plug into the 40-pin header on the board. And usually shields and hats form an integral mechanical assembly when combined with the baseboard. So, and if you just Google for Arduino shields, you'll find literally thousands. And same with Raspberry Pi hats. Don't seem to be quite as pervasive or ubiquitous or common, but but they're out there and they incorporate lots of strange functionality. So those are sort of hardware. That's the names for the hardware boards that plug into the base boards. That's it. AE0BQ.
Okay, and Carrie?
Finally, I got my radio set up so I can talk to you guys, but I want to say just basically the same thing. Now, the Raspberry Pi is essentially a bare bones PC. It comes with a Ethernet port, the Pi 3 anyway, comes with 4 USB ports, and video I/O, and all that kind of stuff on one little computer. And you can hook up a monitor, keyboard, other mass storage units, things like that through the USB. You got 4 ports, so you can use one of them for a keyboard and one of them for a mouse, and the other 2 for just about anything you want to use them for. Anyway, that's a Raspberry Pi. And the Arduino is just significantly simpler because it has a processor, i.e. a computer, and fewer parts to interface with, but on the other hand, it gets the job done. So what can I say? And like I said, you can download compiled code for either one of them and download that into the device and let it run. So, hey, that is kind of the one way to go, rather than learning to program it. But yeah, back to net.
Okay. This is N7GES and the NCARC TechNet. So I don't know if we've talked a lot of specifics. We've talked about ideas and a few specifics. I think there are probably a lot of examples of things on the web that you could do. If you search Arduino and amateur radio, you will find a fair amount of things out there that can be done project-wise. Some certainly will require extra hardware, a small amount of extra hardware. Sometimes an actual shield or extra board. But again, that's not necessarily a real expensive thing. Some of them certainly are not very expensive and provide you a lot of functionality. And then you have the ability then to either completely write your own code, or at least start with a sample or example, and then modify it as you want to do things exactly the way you want them. So I don't have any other examples right now of amateur radio related things, but there are plenty others out there. Does anybody else have questions that you'd like to pose before we finish up this topic, or other comments?
TYU with the announcement when you get done.
Okay, let's go ahead, TYU.
I'll do this at the end, that's fine.
Well, I think we may be pretty much there. Go ahead.
Okay, thanks, Kevin. Appreciate that. We have now booked the REA building, the Poudre REA building, for our tech class, and it will be September 22nd and September 29th for our technicians class. This is for anyone that doesn't have a license that would want to do that, or someone who wants to just sit in on the thing, that's fine. Let me let this drop for a minute. You've been to one of our classes before. It's somewhat the same thing. Basically what it is, it's 2 full Saturdays from 8 to 4. Lunch will be provided, and also we will have a test session on the 29th in the afternoon for anyone who wants to test out. So if you need to get a hold, please send me a note at president@ncarc.net, and we'll get you signed up. The spots are going pretty quickly, so I would definitely, if you're interested or have someone that's interested, please call. So with that, send it back to you. Thanks so much.
Okay, thanks, Joe. Any questions for him? Okay. Before we close, any general amateur radio technical questions, not necessarily involving this topic, that anybody would like to ask before we close the net?
Sign up.
Sorry, I doubled with you. Carrie, come again, please.
Well, Joe, this is Carrie, and you might include the capacity of your place for your classes, because at some point you would have a full filled to capacity and have to say no to some of them, so you just might include that information.
Okay. Once again, any general technical questions for the TechNet before we close today?
AE0BQ.
Okay, I don't know if we had a double or not, but BQ, go.
Right, I just strung up a G5 RV antenna, and I've got an MFJ 993 IntelliTuner tied to it. Seems to be pretty flaky. Two questions here. One is, anybody else use the combination of G5 RV and MFJ tuner, automatic tuner? And how critical is it to have a ground rod at the station? I know it's important, but I mean, is it night and day? I'm going to put one in. I have a ground rod. I have to drill a hole in the basement wall and drive, you know. So I'm going to do that, but is that going to make a night and day difference on my reception? AE0BQ.
P, I can answer the second question.
Go ahead, Terry.
A grounding rod will definitely make night and day difference when you have a nearby lightning strike. It'll make the difference between your radio equipment surviving and it not. W0ASP.
Okay, anybody had experience with a G5RV and an MFJ auto tuner? I was just using a G5RV, not the MFJ, but a what is that tuner? Everybody has them. I can't think who it is right now. I'm embarrassed, but I can't say the name of it. But also an auto tuner. What sort of situation are you running into?
Right. Get to that in a second. This is AE0BQ. So the IntelliTuner, the MFJ tuner, just seems to be all over the map. I understand that the G5RV isn't consistent throughout its response, but it just anywhere from 1.5 SWR to 6 plus. It just doesn't seem to do a consistent job of tuning on different bands. So 10 meters and 20 meters, usually pretty good. Everything else, not so much.
WIQ with a comment about the G5RV.
WIQ, go.
The G5RV is a complex antenna because it has different lengths of wire for matching up to different bands. So you would get a more consistent thing if you only used a dipole. Anyway, that's my view of it anyway. Since you have multiple lengths of antenna, your auto tuner is going to be all over the place because of those multiple lengths. So anyway, that's my comment. Back to Ned.
Okay, anybody else?
ASP with an emphasis on Carrie's point.
ASP, go.
Carrie is absolutely correct that the G5RV is designed to deal with the resonances associated with amateur antennas and amateur bands. And if I recall correctly, they do not recommend using a tuner because the tuner can get confused by the fact that the resonances are already built in to the design of the antenna, W0ASP.
Well, that sure helps me out, too. Was having some interesting situations with mine up at camp this year as well, so thank you. I haven't heard that they recommend you not using a tuner, but that's certainly possible, all right. I've always used my built-in tuner when I had one here, but as they're really supposed to, operate best on certain bands, then you can, use them there, but you might find that they don't work well just everywhere. I don't know, does that kind of help at all? Is it Bill? Have I got the right person?
AE0BQ, name here is Daryl. Well, yeah, I've gotten several. I've got a few different guys that are Elmering me. I'm a new ham, so I'm working from advice. Guy I've known 20 years said G5RV and a tuner, and you're done. Handles everything from 10 on down, right? So, and then I hear things like, oh, no ham sticks, dipoles. It's sort of the purist view that anything that isn't a dipole is good. Which, there's certainly truth to that. The dipole is going to be the most efficient. But, I live in I don't have 25 acres to have an antenna farm, so I get one. I have one mast in the center of my lot, and it's just tall enough to fit a G5RV in an inverted V config. So I'll keep on experimenting, I guess. I think the other brand of auto tuner you were thinking of perhaps was LDG. That's another one slightly more expensive than the MFJ. Came recommended to me by one of my Elmers. I opted to go with the cheaper one. Maybe that was a mistake. I might end up having to Craigslist the MFJ and get an LDG. People swear by those as well, so I don't know. Anyway, thanks for everybody's input. I don't think I'm any better or worse off. My original question was the ground rod at the station. I have the mast. Sorry, I have the coax running through. Is it polyphasers? Right, I have two coaxes, one for the G5RV and one for the J-pole, for VHF, UHF. And so I'm running those through polyphasers mounted in a box on the wall, and those are externally grounded. So I think lightning is covered from that angle. And then having a second ground rod in the basement at the ham shack table, that was my question. Reset break. So the question is, I haven't added that ground rod yet at the station, but when I do, should I expect to see a night and day difference on my G5RV reception? AE0BQ.
And somebody needs to check their APRS frequency, please. Any comment on the reception difference there?
W0ASP.
Go ahead, Terry.
For neither lightning protection or reception interference, should you add a second ground rod to your system. Please have only one, and on the exterior of your building.
DDZ.
Could you expound on that just a little more? Because I had thought I had heard multiple ground rods could be a good thing. I guess I'm a little confused here.
WIQ about ground rods?
Hold on, let me finish with Terry here.
Having one on the exterior of the building and then having another one on the interior nearer to his radios. Is that correct?
AE0BQ, yes, that's correct. I've got, I plan to have, I don't at this point, I'm still working on it. But, the plan is the polyphasers and a pair of ground rods with a strap outside. And then after about another 30 feet of coax, I have the shack is in the basement, so about another 20, 30 feet of coax. Do I need another ground rod into the dirt at the station?
K20HM.
Stand by, we got a question to Terry here.
AE0BQ, W0AS. Opinion, no. Back to net.
Okay.
My understanding, you should ground out to your house ground if you can figure out how to do that.
DDZ.
DDZ, go.
I just wanted to expand on Terry's point. It is okay to have a second ground rod if the ground system is tied together, but you don't want two separate ground systems because that could cause a difference in the two ground systems, which could cause problems yourself. So if you do have a second ground rod at your station, you should tie it to the ground rod that's at your antenna, and it should be a single ground system. W0DDZ.
Amen. Watching the program Ham Nation, they talk about only one ground because if you have more than one ground involved, you end up with a ground current that causes a potential difference, therefore more noise and all that other stuff. So, back to net.
Okay, Daryl, does that help?
Sounds pretty authoritative to me. Ham Nation's pretty well respected. I've read and heard opinions on both sides of this. So, but electrically makes sense if you have two ground rods, one of them being the lightning for the protective circuit on the exterior, and then a second rod somewhere else. You would either need to strap them together very well, or just eliminate and just use the one. And I think, so the lug on the back of the radio I'd probably want to run a piece of bare copper back to the external grounding system, and that way it'll be a single point ground. And assuming my 12-volt supplies are actually floated, switching power supplies actually floated, that should be a single point ground. AE0BQ.
BQ, you are essentially correct. You want to tie the chassis of the radios together so that there's no potential difference between the radios. But back to the ground rods. In this dry soil here in Colorado, or in northern Colorado, putting multiple ground rods in the ground and tying them all together to make one ground is a fairly good idea because of the dry soil.
Okay, we had another station at the same time as Carrie. Come again?
NCARC, and Carrie said it already. Tie it all together, that is one ground. More rods is better.
Okay, very good, and thanks for coming in here, Ken. Appreciate it. Any other questions for the net today? Was a double, one at a time, please.
KE0 SPF.
STS?
Sierra Papa Foxtrot. I just want to say hello everyone tonight. This is my first day as a technician. It's great to be with y'all. My question tonight is, if I want to go about using Echolink, especially through my Bofane, how would I go about using the DTMF codes to get connected to another repeater across the country?
Well, as far as most repeaters that will let you do that, you simply enter the appropriate node number, and probably it may require you to end with a star or something of that nature, but I think that might be somewhat repeater specific. We have a procedure on this repeater that is supposed to work. I haven't seen it work yet, and I don't know if we've had anything that's fixed at that. But there is a code sequence that you're supposed to be able to enter, and then enter the node number, and that will connect you. But I don't believe it's currently working on this machine. If you use KC0RBT machine, which is 447450, that one will work that way right now, and I believe it just requires the node number and maybe a pound sign, but that one I'm not sure of. So you'll have to check that out a bit further. Ours is supposed to work that way as well, and it requires a little access code that you dial first and then dial the node number. But I don't know that they've got it working yet. Anybody can correct me if they know something different here within the last couple of weeks. Anyway, just make sure that you hold your push-to-talk, dial your numbers, and make sure you know which is star and which is pound. Sometimes that's a little confusing on the Baofeng, I guess. Maybe they're fairly clearly marked, I don't know. But then you should be able to dial right through. I know that I believe it's been done here. I know it's done on Jim's machine, KC0RBT, fairly often, and works fine there as well. So yes, it's doable. I can't tell you the specifics, but did I give you a little more information that will help?
Yeah, Kevin, that did help. And I guess the sub-question would be, are there any other options for me other than Echolink to contact repeaters outside of Colorado?
Well, there is another system called IRLP. Again, that's done with there is no way to go into an app on the internet to access that. That is strictly done radio to radio. Even though the communications happens over the internet, you access it via radio. You'd have to look up which repeaters cover IRLP and then connect it that way. So that is another option you have.
The WIQ is an expansion.
Go ahead, Carrie.
Communicating even internationally can be done by either the systems that have been most spoken about. The one that I have gotten into fairly recently is called D-Star, and that requires a D-Star radio, but which is not the cheapest radio in the world, but yeah. But use D-Star and connect to any place in the world that D-Star goes, which is virtually everywhere the internet goes. So, hey, that's my comment.
Okay, any other questions? Let me see. That was Kevin. Should remember that because that's my name.
K1 DEG.
Ed, Mike?
Yeah, I have a question, but this is a different subject. But TYU did key up right as you keyed up, so let him go.
Okay. Seem to have a bunch of things there. Joe, go ahead.
Another way, I guess you can get out, I don't know if it's to a certain repeater or not, but James has got Wires X working out of the Budweiser repeater, so that would be another thing. We just learned about that on Saturday, so that's up and running.
Okay, very good. Does that help you, Kevin?
Yeah, that gives me a lot of research material. Thank you.
Okay. Well, and then there's also DMR. Yeah, there you go. But as far as your basic Baofeng, the two main options there, I think, are IRLP and Echolink. And they both do work, but of course they depend on having a repeater at both ends that is equipped with the appropriate connectivity. Of course, you know that you can connect to Echolink via an app on your computer or phone, so that if you don't have a repeater that you can dial through, you can connect that way as well. So, that's another option there for you. This is N7 DES with the TechNet. DEG, your question.
Well, my question is about a scanner I purchased. I have a Uniden SC230. It's one of the NCARC scanners, and I was curious if there was anyone that has the programming cord, and the programming app that would program the scanner. I'm trying to find someone that would have that, so then that way I can get it programmed. If not, that's no big deal. There's also a scanner net, but I can't remember what frequency and time and yada 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 on it. But if anybody's got any information that can help out, that would be appreciative. Thank you much. This is K1DEG, Mike in Platteville.
Mike in Platteview, that net is on the 147225. If you can reach that, you can listen to that net, but they have many other nets also, so you might have to find a schedule for that net.
Okay, thank you, Kerry. Anybody help out on the programming cord and software?
This is TYU. How old is the radio?
K1DEG for ID. TYU, I'm not exactly sure. Honestly, it's I really don't know. I'd have to look it up on the internet and see when it was released, but I haven't even thought about doing that.
I've got one somewhat similar, but it's probably 15 years old. It's up at the shed right now. I think I did program it. I think I programmed it manually, though. I don't think we use software for it. I think I manually programmed that. I guess I'm not sure the software you're talking about.
And that's understandable. I've tried to program it, but I do not think I've had any success with that. So that's why I was reverting to the software and the programming cable. Did look it up and pulled the owner's manual, and it suggests using the software and the programming cable. So my thoughts was is that should be a little easier, and that's what I was looking for. That's all.
Yeah, I totally agree with that. Let me do some looking. Like I say, it's up the shed right now. I don't have it. I actually know exactly where it's at in the shed. Let me go up there and take a look sometime this next couple days or something like that, and I'll see if I can pull it down. Maybe I'll give you some information on what I've got. I got the same thing. It's a handheld NASCAR type thing with headphones, right?
You know, I didn't get the headphones with it, but yeah, you've got the idea. Supposedly, the way it seems in the menus, that if you have two of these scanners, you can transfer information from one to the other just by going into the menu and telling it to send it. It must do it wirelessly or something like that. I'm not exactly sure, but Yeah, that's what I've found. I haven't had no luck at, really getting through it. All I've been doing is letting it do its pre-scan or whatever you want to do it, this programming scan.
Copy that. I'll look at that. I mean, mine goes back to when PPIR was down here in Colorado Springs. That's the last time we used it. So, okay, I'll let you know.
All right, TYU, you do have the model number, correct?
No, give it to me one more time.
All righty, it's Sierra Charlie 230.
Familiar. Let me look.
Okay, we have definitely overrun time here, but I'm glad that we've been able to answer a lot of information and a lot of questions, and I hope we've given you folks some good ideas on what you might do with these wonderful little computer and processor devices, because they're very, very accessible now, inexpensive, and easy to get at. And I think using a bit of imagination, there's a lot you could do with it. So I hope we've given you a starting point to jump off of. If you have more questions, please do feel free to address them to Elmers at ncarc.net. That's also the place to address any questions about this net or questions you'd like us to pose on the net for people to answer. Don't forget that we have our YouTube channel where our programs are streamed live and where they are archived as well for future review. If you just look up NCARC on YouTube, I believe that will come up right up for you. I will have to get back on with you on the topic next week because I did not get that researched. I apologize to all for that one. It's been a crazy week here, and I think this has been one of the hardest times I've had getting over camp. I guess I'm getting old. I don't know. Anyway, I will get a topic posted on the web page as soon as possible, and I apologize for not having that done earlier. But we'll get one up shortly, and do be looking for that. So thank you all for participating, and hope you've enjoyed it. Do please communicate with us if you have questions or thoughts or suggestions or ideas. We'd love to hear from people to know that we're filling a need here properly. Thanks again for the time, and we'll now return the repeater to normal use. This is N7GES, and I'll be clear.
This presentation was brought to you by the Northern Colorado Amateur Radio Club. Thank you for watching, and don't forget to like and subscribe.